we are continuing chapter 6, section 1, dealing with basically the properties of exponents. Okay? This number right here is a power, or an exponent. Whenever you guys have it on the outside of the parentheses, you need to apply this power to every single possible number or variable inside of the parentheses. So even though you can't see it, that is 2 to the first. This is 3 to the first. So in the numerator, here's what we're going to have. In the numerator, you're going to have a 2 to the power of 1, and that right there by itself is going to be squared. So right here in the numerator, you are going to end up having 2 squared, which becomes a 4. So that's the number that's going to be right here in the numerator. In the denominator, you're going to have a 3 that's being squared. You're going to have an r squared that's also being squared, an s cubed that's being squared, and z to the power of 6 that's also being squared. You're wondering what the heck I'm doing right here? This 2 is being applied to every single number or variable inside of the parentheses. Now, yesterday we talked about what is a power of a power. What do we do when we have a power of a power? We do what? Oh, multiply. We multiply. Power of a power, we multiply. So let me go over the concept that you guys need to understand the difference. If I were to say a squared times a to the third, that would be a to the power of 5. But if I were to say, what is a squared raised to the power of 3? This is the power of a power. That's going to get me to a to the 6th. You need to be able to see the difference between these two types of problems. This problem, what do we do with these numbers? This type of problem, we add. This, we multiply, because here we have 2 powers right next to each other. So right now, we have 3 squared, that becomes a 9. Here, we multiply them together, it becomes r to the 4th. Here, we multiply them together, it becomes s to the 6th. And here, we multiply, that becomes z to the power of 12. This is the term that's going to be in the denominator. Here's our final answer. 4 over 9 r to the 4th, s to the 6th, z to the 12th. There are no negative exponents, and all the parentheses are now gone. So if you're going to solve this, remember, yesterday we talked about, to simplify an expression, it says, you rewrite it without parentheses or negative exponents. This is the answer without parentheses or negative exponents. And we have to know when are we allowed to add the exponents, when are we allowed to multiply them, and sometimes when are we allowed to subtract them. All right, moving forward, number 8 looks ridiculously harder than number 6. Same kind of problem. What's the only difference? That has a positive 2. This has a negative 2 as an exponent. So what I'd like you guys to do in your journal, before you write down problem 8, I would like you to do this. I'd like you to put an open parentheses with the letter A over the letter B. We are going to take that fraction and we are going to say, we're going to raise that to the power of a negative number, some negative in value, which just represents a number. I want you to write equals B over A to the power of the positive version of whatever number you have. And we'll use some regular real numbers, like a real fraction, so you can show you how it works. Okay? So let's think about this. My A value goes from the numerator to the denominator. My B value goes from the denominator to the numerator. And my N value just goes from what? Negative to positive. Alright, so let me show you how this works. You ready? I'm going to use some numbers now. I'm going to call A 2. I'm going to call B 3. And I'm going to raise that letting you know right now, this would equal 3 over 2 raised to the power of 2. Now, what's my final answer going to be for this one? What is 3 squared? 9. What is 2 squared? 4. So if you were to put this in the graphing calculator, everybody, like that, your calculator is not going to spit out this. Your calculator is going to go directly to your final answer. Okay? So right here, if I were to go open parentheses, alpha y equals enter, type in 2 here and 3 here, and close the parentheses and raise that to the power of -2, it's going to spit out what? 9 over 4. So it kind of skips a step, doesn't it? It doesn't show you, calculators don't show you the process, they just show you the final answer. But this, what does this actually become? It becomes 3 over 2 squared. Okay? The reason why I'm showing you this, hopefully you guys understand why I'm showing you this, because this whole thing right here represents my A. This right here represents the B. There's my negative exponent. Okay? So let's think about how we could rewrite this to make it a little bit easier of a problem to solve. What number am I going to put up there in the numerator? Negative x squared. Y to the fifth. Very good. What number am I going to put in the denominator? Good. 2x cubed. Y squared. But the only thing that's different is what? Ah. So let me make sure you guys see the pattern here. This right here goes down. This right here goes up. And the exponent changes from negative to positive. So if you guys would please go and write that down in your journal, we'll go from there. All right, now that we have this written down in our journal, this power of 2 is going to be applied to every single number inside here. So I'm just going to focus right now, everybody. I'm going to focus just on the numbers in the numerator. Even though you can't see it, that's a -1. So I'm going to say -1 squared. Then I'm going to say x squared. Then I'm going to raise that to the power of 2. Then I'm going to say y to the 5th raised to the power of 2. Understand, every single number and every single variable, I've applied the power of 2 in the numerator. So let's evaluate what we have right here in the numerator. We're just going to evaluate just the numerator, then we'll worry about the denominator. A -1 times a -1, yes, is a positive 1. So those cancel out. And x squared raised to the power of 2 becomes x to the 4th. Y to the 5th squared. What are we allowed to do with these once again? We're taking these in, multiplying them together. That becomes y to the 10th. And that right there is your final answer in the numerator at this point. Probably have to be able to go a little bit further, but that right there is the simplified answer in the numerator. Now we got to look at the denominator. In the denominator, we have a 2. What's happening to 2? It's being squared. What's happening to x cubed? It's being squared. And finally, y squared is also being squared. Hopefully you guys see the pattern. Every single number inside of this parentheses is being squared. 2 squared is 4. This becomes what, everybody? Good. And this becomes? Good. So right now, everybody, this right here is what everything has led us up to. No need to hurt yourself right now. It's almost over. Alright? So x to the 4th, everybody. We have y to the 10th over a 4, x to the 6th, y to the 4th. Now, the last thing we have to worry about is this. We don't have to worry about the power property. We have to worry about the quotient property. Okay? Now, which is the easy one to worry about when you're looking at it? X or y? Which is the easy? Y. And y. Because what are we going to be left with up right there in the numerator? We're going to be left with y to the 6. Because 10 minus 4 is 6. Now the 4 just stays where it is. This 4 just stays where it is. Doesn't move anywhere. Just stays right there. But this is where students mess up. They'll go x to the 4 over x to the 6, and they'll say that's equal to x to the negative 2. But they're like, what the heck does x to the negative 2 actually mean? It means 1 over x squared. So what's going to actually be in the denominator? An x squared. And let me show you logically why that's the case. X to the 4th means what? X times x times x times x. I'm not going to list this one. But I would have to list how many x's in the denominator if I wanted to simplify that. There's 6 of them, okay? Well, all of these, guys, all of these cancel out. But how many right here are still left? Still left with a 2. Yeah, you still put these through. Because you don't need to put the negative. This becomes x to the negative 2, but that becomes what? It becomes 1 over x squared. There's the 1 over x squared right there. Okay? So your final answer. This is your final simplified answer. Okay? Y to the 6th over 4x squared. Now, some people might have done this. They might have put y to the 6th, x to the negative 2 over 4. I've seen that answer, that type of answer before. What would this student have forgotten to do? That you're not allowed to have what? Negative exponents. And all you have to do to make a negative exponent positive is either shift it down below or move it up, depending on where it is. Is it in the numerator or is it in the denominator? That's why that's your final answer.